Okay, so we're asked to find the exact values, which means we can't plug these in a calculator. Okay, for these questions, we have to figure out what they are using some facts about sine, cosine, um, guess the Pythagorean theorem. So to do these problems, there's different ways that teachers teach them. Some teachers say you just got to memorize these particular values. I was always a teacher that said, well, let's reduce the amount of things that we need students to memorize. And I've boiled it down to just a few numbers. So you want to memorize these two triangles, okay? And they're right triangles. And the first triangle is the 30-60 triangles. 30 degrees one angle, 60 degrees the other. It doesn't matter which one's 30, which one's 60. But the one that's 30 degrees is always drawn, sorry, this whole triangle, both of them are always drawn in the unit circle. So that means they have a hypotenuse of 1. And the side that's opposite of 30 degrees is always 1/2. And so the side opposite of 60 degrees is square root of 3 over 2. Okay, so if you memorize the values of that triangle, if you memorize the values of this triangle, which is a 45-45 triangle, this one's easier to memorize because look, if the hypotenuse is 1, then these have to be the same, and they have to be square root of 2 over 2 by the Pythagorean theorem. So memorizing those two triangles, you can get all these exact value triangles, and I'll show you how. Okay. So cosine pi over 3, you could convert that to degrees. You cut out the pi, so that means you're left with 1/3. And then you multiply the result by 180. So the cosine cosine pi over 3 is the same thing as cosine 60. So start by drawing a 60-degree angle. Oh, here, I didn't explain that part yet. Here's our 60-degree angle. And then make it into a triangle by making a right angle with the x-axis. Okay, so you draw straight down, and there's our right angle. Okay, and we said that this angle was a 60-degree angle, right? So based on those triangles I've said we should memorize, what side is supposed to be corresponding over here to 60 degrees? That's square root of 3 over 2, right? And it's always drawn in the unit circle, so we call that 1. So that means the only other missing side is the one that's across from what would be 30 degrees up here, so this would be 1/2. Okay, so now you have a triangle where you can say the cosine ratio. Cosine is not the opposite divided by the hypotenuse. Cosine is the adjacent divided by the hypotenuse. So this is 1/2. There's our answer. Okay, so there's a lot. That's why I have another problem for you. Sine of pi over 4. Convert pi over 4 to degrees. Cut the pi out and then multiply 1/4 times 180. You'll get a 45-degree angle. So that means that this is the right angle. Like I said, you always draw that angle first and then make a right angle with the x-axis. And the 45-45 triangle is easy to label because the hypotenuse is always 1. And that means either side is square root of 2 over 2 because it's isosceles. So sine would be what's opposite of 45 divided by the hypotenuse. So sine is square root of 2 over 2. Okay, let me do one more. Let's do cosine pi over 6. Okay, if you convert pi over 6 to degrees, that's 30 degrees. So here's my 30-degree angle. And I always make here's the angle. And I always make a right angle with the x-axis, so I'm going to bring this down. And according to our special triangles, 1/2 is always supposed to be opposite of 30. So in this triangle I just drew, I'm putting 1/2 over here. We always have a hypotenuse of 1. And so that means this side is the only side that's missing. And up there in the special triangles I wrote, that's square root of 3 over 2. Cosine is the adjacent divided by the hypotenuse. So the adjacent of angle 30, the adjacent of pi over 6 in other words, is square root of 3 over 2. And the hypotenuse is 1. So square root of 3 over 2 divided by 1 is square root of 3 over 2. Okay? Maybe even one more. Okay, sine pi over 6, that's the same angle, right? So I don't even have to do any thinking there. It's still a 30-degree angle. I still know all the side lengths. 30 degrees always corresponds with 1/2. Square root of 3 over 2 has to be over here. Sine is what's opposite of 30 divided by the hypotenuse. So what's opposite of 30 is 1/2. The hypotenuse is 1. So 1/2 divided by 1 makes 1/2. So that's what sine of pi over 6 is. Okay, and then I made these two last ones over here. These are special ones because look, if you convert pi over 2 to degrees, it's radians right now, but if you convert it to degrees, you cut out the pi and multiply by 180. So 180 times 1/2 makes 90. This is a 90-degree angle. And for these ones where they land right on one of the axes, you can't draw a right triangle with the x-axis, right? So this is, you can find out these values by figuring out what the point is here. So cosine pi over 2, if we're drawing this in the unit circle, then it's 1 unit away from the origin, right? So on the x-axis, it's at 0 on the x-axis for this point. And the y-axis, it's 1 unit up. So that's the point that represents the terminal side of pi over 2. And the quick way of doing these ones where they land on an axis is that cosine is always the x-coordinate. So cosine pi over 2 is 0. Okay? Sine is the y-coordinate. So sine of pi over 2 would be 1. Okay? So let's do the same thing for this one. 3 pi over 2, cut the pi out, multiply by 180, then you've got a 270-degree angle. Lands right here. Now think carefully about what that point is. It's gone nowhere on the x-axis, so it's at 0 on the x-axis. And it's gone down 1 on the y-axis, because again, this is always 1, right? It's the unit circle, so the radius is 1. But that's down, so that's why I'm putting a -1 there. Sine are always the y-coordinates of points on the unit circle. So this is -1. And that's it. That should be all the different types of problems you see for this part.